In this video, we'll be doing the CBSE Class 9th Science Chapter 8 Journey Inside the Atom. This is as per the new NCERT syllabus exploration. Let's start with understanding what is an atom. Everything we see or observe or feel around us is called matter, and all matter is made up of atoms. Let us look at a rediscovery of atomic theory. Well, Acharya Kannada, the ancient Indian scientist who actually dreamed of the atom, gave up the theory that all dravya, which is matter, is made up of Parmanu or atom. Leucippus and Demosiritus coined the term atomos, which means indivisible, in the Greek mythology as well. Later, John Dalton discovered the atomic theory that says all matter is composed of indivisible particles called atoms, and atoms are the fundamental building blocks of everything that is matter. It cannot be broken down into smaller parts. Well, let us look at the historical journey through which each atomic model was discovered. The atomic theory given by Dalton, which said that atoms cannot be broken down, was later discarded because of the following reason. Certain elements emit invisible energy and particles, which is called radiation, and this phenomenon is called radioactivity. So this showed that atoms must be composed of smaller particles, proving that they were not indivisible as believed previously. J.J. Thomson conducted an experiment called the cathode ray tube experiment, where he studied the conduction of electric current through the gases at very low pressure. He concluded that there are streams of negatively charged particles with much smaller masses than atoms, and these were later called as electrons. Later, J.J. Thomson came up with an atomic model, which is also called the Thomson plum pudding model, where atoms could be a sphere of positive charge with electrons distributed through it. It replicates that of a plum or a pudding or something similar to a watermelon, hence it is called the plum pudding model. Later, Gregor and Madison, who worked under Rutherford, tested this Thomson's model through the gold foil experiment. They aimed a narrow beam of alpha particles at an extremely thin sheet of gold foil, so they expected that alpha particles to pass straight through the gold foil and or be deflected only slightly. But to their surprise, most particles passed through undeflected, some were sharply deflected, and few even bounced back. From this experiment, Rutherford came up with an atomic model called the planetary model of atom, where most of the atom space was considered as an empty space, and electrons were considered to be revolving around a nucleus. Nucleus is something which is dense and contains all the positive charge, which has most of the mass of the atom. This explained the neutrality of the atom, where it was electrically neutral, as equal number of positive charge and negative charge was present in the atom. But it could not explain the stability of the atom, as any particle moving in a circular path undergoes acceleration, as we have seen. But this particle would lose energy eventually and spiral into the nucleus. So hence it failed explaining the stability of the atom. Coming to the next atomic model, which is of Bohr, Niels Bohr came up with an atomic model to explain why atoms are stable. He proposed this model where electrons do not move randomly in the nucleus but follow fixed circular paths called stationary states, orbits, or shells. In each shell, the electron has a definite amount of energy, so these shells are also called energy levels. Electrons do not lose energy while moving in this fixed shell. Each shell can hold only a certain number of electrons, and the shells are given by the letters K, L, M, N, with N equals to 1, 2, 3, 4, etc. The energy levels of these shells increase as we move away from the nucleus. An electron can move to another shell by either absorbing or releasing a fixed amount of energy. Later, even Bohr's model was considered to have limitations, and yet another model which is currently used, the quantum mechanical model, was proposed, which we will see in further classes. What constitutes the mass of the atom? Under observation, came to know that hydrogen, which has only one electron, and helium, which has two electrons, weighed much heavier than that of hydrogen. Considering the number of protons and electrons in this, the weight difference was considered huge. Thus, James Chadwick discovered another subatomic particle called neutron, which is present in the nucleus. Mass of this was equal to that of proton and had no charge, and hence the mass of an atom was given by the mass of the protons plus the mass of the neutrons. So hence we discovered three subatomic particles, electron, proton and neutron, with their symbols and charges respectively. Later, scientists wanted to discover how to represent different elements under a uniform manner. John Dalton proposed to maintain uniformity, introduced a pictorial symbols of each element to represent them. Later, the International Union of Pure and Applied Chemistry came up with symbols of every element where the first two letters or another letter of the name of the element is used, and the first letter is written in uppercase and the second letter is written in lowercase. In some cases, the Greek, Latin or German names of the elements are also used, such as iron comes from ferrum and tungsten came from wolfram, which is German. Understanding atomic number and mass number. Let us consider the element carbon. Atomic number is the number of electrons in this element. Mass number, which is given by A, is the number of protons plus neutrons in this element. So, the number of electrons is 6, the protons are 6 and neutrons are 6. Hence, the atomic number of carbon is 6 and the mass number will be 6 plus 6, 12. The atomic number and mass number of an element is written as follows, where the mass is written above and atomic number is written below. Well, carbon would be written as follows. Moving on to how electrons are distributed in different energy levels. Well, as we have seen the 4 shells discovered by Bohr, the maximum number of electrons in a shell is given by 2n square. Hence, the K shell can hold 2 electrons, L can hold 8 electrons, M can hold 18 and N can hold 32. The innermost shell can contain a maximum of 8 electrons. The innermost shell can contain a maximum of 2 electrons. Electrons are filled in these shells in a stepwise manner from K to N. That is, first the K shell is filled, then the L shell, then M and then N. Moving on to the combining capacity, which is also called valency. So the outermost shell of an atom is called a valence shell and the electrons in it are called valence electrons, and when they complete an octet, that is when they have 8 electrons in their outermost shell, they are mostly stable, hence called noble gases, which are helium, neon, argon, etc. All elements try to complete their octet either by gaining, losing or sharing electrons, and the number of atoms available to gain, lose or share is called the valency of that element. Here, lithium can lose 1 electron, hence its valency is +1. Oxygen needs 2 electrons to complete octet, hence its valency is -2. This is how the valency of an atom is written. Moving on to isotopes and isobars. Isotopes are elements which have the same atomic number but different mass numbers, such as different kinds of hydrogen that are present. Each isotope has a different mass number as the number of neutrons are higher than that of the previous one. Examples of this are 3 different kinds of hydrogen. Oxygen also has 3 isotopes, carbon, silver, etc. Chlorine has 2 isotopes. Now, when there are 2 isotopes, how do we calculate the atomic mass of the element? Well, we can do the average atomic mass, where we take the mass of all the isotopes and divide it by the number of the isotopes. Well, this doesn't consider abundance of each isotope in nature. Hence, we use the weighted average atomic mass, where mass of the isotope is multiplied by the percentage relative abundance of each isotope and added together, divided by the number of isotopes to give an average weighted atomic mass, which is the final atomic mass of that element. Isobars. Isobars have different atomic number but same mass number. Again, this is also due to the different number of neutrons, such as argon, potassium and calcium all have different atomic numbers but have the same mass of 40. Similarly, nickel and cobalt have the same mass of 64 and sodium and magnesium have the same mass of 24. These are some of the isobars that we know. This completes the chapter Journey Through the Atom. Hope you have understood it well enough. Like this channel and subscribe for more such content. Comment below on which topic would you like for me to make a video on.